today is the 30th, right? Okay. Good. Simplifying by factoring. Okay, let's start with a very simple example. Here it is. Let's say I have the following polynomial. 2x to the 4th plus x squared minus x. And I see that this polynomial has how many terms?
3.
Good. And I see that it has something in common.
X.
Yes, so x will be factored out, indeed. How many terms do I have to have left in parentheses?
3.
Absolutely 3. If I have anything else but 3, something is wrong. Good, perfect. So now, how do I think? There are several ways. Here's one way. What times x is this? 2x cubed. That's one way. Or you can say this divided by this is this. Whatever works for you. Then I have to have plus x and minus 1. Correct. Now, here's another way of thinking about it, because this is what I need right now for what follows. I'm looking at 1, 2, and 4, and I say, okay, what is the largest power that goes into all of them? And the answer is 1. Power 1. Okay? And then I say, okay, 4 minus 1 is 3. So please follow this, because this is what I need for those sophisticated kind of expressions. 2 minus 1 is 1. Oops, sorry. 1 minus 1 is power 0. So this is basically x raised to 0, which is 1, as long as x is not 0. So this is the concept that we are going to apply in all these problems. So I'm looking at this handout. Whoops, I have it right here now. And I would like to start with these problems. Feel free to choose, because whatever is left, you're going to have to work on. All the answers are here. If you do not get this answer, you have to let me know. But for now, let's choose whatever catches your eye. And let's say 3 examples, 3 problems. You choose. Ready? Okay, number 1.
11.
Number 11. Perfect. And something from here. Okay, perfect. So we're going to cover 1, 11, and 15. I'm going to do one that you want me to do. And then the next 2, you're going to dictate to me what I need to do. You're going to explain it to me. Okay? So please choose one for me. 15. Very good. You make it harder on me, I'm going to make it, no. Just kidding. Just kidding. Okay, so this is 15 from our handout. I'm just going to copy it right now. The cube root of x squared plus 3, outside multiplied by -1, also multiplied by x to -2, plus 1/3 in parentheses, x squared plus 3 raised to -2/3, and in parentheses 2x, and then in parentheses x to -1. Sometimes I copy incorrectly. It's possible. I don't know, because I'm standing, because I don't know, I need new glasses. I have no idea. No excuse. So please make sure that I copied it correctly. Okay. First thing I ask myself is, how many terms do I see in this expression? Okay. Coming back to our example. How many terms did we see in that problem? Okay. Good. So now let's look.
5. Oh, yeah. 2. 2.
Exactly 2.
There's the plus.
Exactly. This is the first term. Extremely important to identify from the beginning what we're given, right? And this is the second term. Absolutely. That's the key. Would you agree?
Yeah.
Now, is it clear? Coming back, let's come back to this. Is it clear? We have 3 terms.
Yes.
1, not 1, 2, right? This is a product. A product by itself is 1 term. As long as I don't encounter a plus or a minus, I don't have terms, right? So 1 term plus another term minus the third term. Good. Excellent. Now we know when we look at anything. So for example, if I ask you how many terms we have in 11.
2.
Right. How many terms we have in 9?
2.
How many terms we have in 4?
2.
Right. Because all this is a product till I encounter a single plus. And then a product.
So for number 5, would that one be 2?
Yes, because this is 1 term and this is 1 term. It happens that it also has a denominator. So it's a different story. We can also choose a ratio if you think so. Okay, good. So is it clear how we look at this expression? That's the very first step. Perfect. Now, I look at these 2 terms and I see that they are not fully simplified. A lot of multiplication. It wasn't there, but I know it's there. It wasn't written, I should say, but I know it's there, right? There is another multiplication here, another one here, and another one here. So first of all, I will put the numbers in front and the portion of the term that can go in front. Let me remind you one thing. Is 2 times 3 the same thing with 3 times 2?
Yes.
Right. So this term, I can rearrange it the way I want. I can put a minus in front. I can put an x to negative 2 in front and then followed by this. I can put this in front and this following it, whatever I want. I can rearrange these factors as I please. And here's what I'm going to do. I'm going to write the equal symbol. I'm going to copy negative x to negative 2 as my first step. So these 2, don't cross them out, I'm just making a point. These 2 are here now. Obviously, I have to multiply. I may need to put the raised dot or not. I look at this, and yes, I peek in the other term, and I see this. So obviously, one can be changed into the other because any fractional exponent is nothing else but a radical. How do I change this to look like this? Exactly, because I know that the cube root means power 1/3. Thank you, Ian. Very good. The cube root is the same with power 1/3. We agree? Okay, perfect. So now, I hope you agree also that this term looks more human, or somewhat. Okay, then I'm here with plus. Again, I've reached this point. I'm looking at this, and I'll say, no way. This is not fully simplified. And I see that I have 2 actually times x to negative 1 times 1/3. But I know what is x times x to negative 1. Copy the base. What do I do with the exponents? Add. How much is negative 1 plus 1? And how much is x to 0? Because x is not 0. We know that. Okay. So this is just 1. So in front, I only have what? Over? Yes. 2 over 3. X squared plus 3 to negative 2/3. Okay, I'm coming back here. because now I'm ready. What did we choose as the factor to go out? Right. To which power? To the first power, which was the smallest, right, of these three. 1, 2, and 4. 1 was the smallest power. Okay, now I'm here. Can anyone tell us which common factors or which common factor these two terms have? Forget about the power. I just want you to say the common factor is blah. When we say a common factor, we are really asking ourselves, what is the portion that is the same in both? Right, that's the exact. I knew that that was something that we needed to talk about. Okay, perfect. But I have to talk about the power. And yes, I'm coming back one more time. Which power did we choose here?
Number 3.
Negative.
Negative 1.
Negative 2/3. I have to compare them. The lowest. That's why I came back several times. So which power did we choose here? Among 1, 2, and 4, we did not choose 2, but we chose 1. Why? Excellent. So now please tell me which power will you choose for x squared plus 3? You have to. Excellent. Perfect. Coming back to my simple example. What did I say? How did I get the 3? Subtracting from 4, 1. How did I get power 1? Subtracting from 2, 1. How did I get power 0? Subtracting from 1, 1. In the same way I have to proceed. Ready? So from this term, first of all, negative x to negative 2 has to be left alone. We have no choice. But now, coming back, this was like the 2 here. This was like the 2, right? Okay. Now coming back here, from which power I subtract which power? Coming back. From power 4, I subtracted power 1. Exactly. 1/3 minus, careful, in parentheses, negative 2/3. That's the key. Exactly. So what do I write in parentheses then, and which power? And what do I have? This is the power. But what do I have in parentheses? That's it. You can check if you want. This times this will give you that for sure. One more time. This times this will give you that, because this times this will give you this. Are you with me? Everyone? Okay. Now I reached this point. Because I have 2 terms, how many terms do I have to have in brackets? Right. So right now I'm at this point where I put the plus, and now you tell me what is left as the second term. That's it. Because we took out that x squared minus plus 3, negative 2/3 minus negative 2/3 will be 0, which means power 1, which means 1 to 0, which is 1. Okay. Now, look what I did. And no one noticed. I didn't copy the correct factor. So please put the negative in there. It's negative. Okay, good. So now I have this at this point. I know that I have to simplify in brackets. This is not done. Simplify in brackets. And remember, any exponent, any quantity with a negative exponent goes where? Yes, to the denominator. Excellent. So I'm going to just put this aside. So yes, I have x squared plus 3 raised to 2/3. Perfect. And now I'm trying to simplify the top. So tell me the product. Yes, you had to. Okay, x to negative 2 times x squared. How much is that?
Negative, not negative 1?
Yes, with negative. But I just said x to negative
Yeah,
2
sorry.
times x squared. You're right. You're right. It is negative 1. Right? Copy the base. Negative 2 plus 2 is 0. X to 0 will be 1. Okay. Now I have to distribute it to 3. So it's minus 3x to negative 2 and plus 2/3. Right? I distributed negative x to negative 2 to both terms and then plus 2/3. I know that 2/3 minus 1, if I only have 2/3 in my pocket, but I owe you $1, then I'm still 1/3 in minus. Good. So negative 1/3 minus, I hope you agree with 3 divided by x squared. Do we agree with 3 divided by x squared? Okay. Now I continue. Any questions so far?
Can you repeat the last step?
It's the negative exponent that goes to the denominator.
Gotcha.
Was that the question? Oh yeah. So then the least common denominator in the numerator, since both terms are negative, I would like to pull it out. So please give me the least common denominator. Very good. Indeed, 3x squared. So what is the adjustment for the top?
X squared
Very good. X squared here
plus,
and 3 here.
yeah, so
Good. The minus is outside. Everything is positive because they're both negative. So this is x squared plus 9. Now careful. Be very careful. See where the equal symbol is? Which means the numerator is a fraction. And I can always make the denominator into a fraction because 5 is 5 over 1. X squared plus 3 to 2/3 is the same with x squared plus 3 to 2/3 over 1. Finally, how do I divide two fractions? Right. So I have to put the minus in front now of the fraction line. I will have x squared plus 9 over 3x squared multiplied by 1 over x squared plus 3 to 2/3. And of course, this will become x squared plus 9 over 3x squared. I could have skipped this step. You can if you want to. X squared plus 3 to 2/3. I would be curious to see what Maple does with all this. It should do it. Give it a shot. Let me know. Okay, very good. Now it's your turn. This was 15. Let's work on 11. Any questions again on this? Okay, so it's x plus 1, negative 1, x squared minus 2x plus 4, raised to negative 2, parentheses 2x minus 2, plus x squared minus 2x plus 4 to negative 1. Before I forget, we do not meet on Monday. School is closed.
Yeah.
It's not a good idea. We're going to have to work harder. On this problem, everyone will participate, so be ready. How many terms?
Two.
Okay, perfect. Can anyone give us the simplified form? Shane, would you like to try? Just the first term. Simplified form of the first term.
So would you put the would you put the one with the negative exponent on the bottom? Would you make it a fraction?
Which one? This one?
Yes. That
No, not yet.
Okay.
Not yet. Very good question. See, we only did that at the very end,
Okay.
after we factored out, and yes. At this stage, I will not. I will just simplify each term. Good. So, Parker, go ahead.
You would get negative x minus 1.
Yes, but I will not distribute it.
You just put a negative
I just
exponent
will rearrange it.
Okay.
And x plus 1, 2x minus 2 if you want, x squared minus 2x plus 4 to negative 2. And obviously, there is nothing I can do to the second term.
Right.
Yes, Ian, go ahead.
Can we, well, I was gonna say is, well, can I tell you what I think of?
Yes?
Like, would it be negative 2x squared minus 2 over 2x minus 3?
That's the final form?
Yeah.
Oh, we're not there yet.
Okay, so, well then if that's at this step, I would,
Yes?
you know, like to say FOIL, but I would, distribute x plus 1 times 2x minus 2.
Nope.
So it'd be-
Nope. I'm not saying it's wrong. I just have to look at what you did, but I recommend something else. Yes.
Would
Nick?
So we're working on the left side term, right? Still, or the right side?
It's simplified completely. You cannot do it.
Since you have a negative exponent, and you have an exponent inside, wouldn't you distribute that negative exponent to all the other ones? So,
That's not possible in a polynomial.
okay.
Not allowed.
Well, we go ahead and pull out our GC
Exactly. The
so we
least
pull out-
common
so we
denominator.
pull out the x squared minus 2x.
Indeed. Minus 2x plus 4. The question is, which power?
We pull out the negative 2.
Exactly. That's the next step that I recommend. Your method may work fine. Okay, perfect. Now what? Bless you.
So we just take it from each side. We rewrite x plus, well, negative x plus 1. 2x minus 2. Plus.
What is the process I have to perform? What is the procedure?
So
From negative 1, I subtract
negative 2.
negative 2.
So you add 1.
Yes, which means power 1.
Yes, it's power.
For that term, for that factor, yes. So this is x squared minus 2x plus 4. Good. Now, yes, Parker?
We pulled out on the first term, we pulled out a negative 2 as the exponent, not a negative 1.
The smallest of the two. Let's go back.
Oh, yeah, okay.
Always the smallest. Among 4, 2, and 1, we chose 1.
Yep.
We cannot choose 2 or 3. We have to choose the smallest. Same procedure here. That's why I always go back to a simple example. Same procedure here. Between negative 2 and negative 1, the smallest of the two is negative 2. I cannot choose anything else.
Okay.
Good. So then what goes to the denominator?
X squared minus 2x plus 4 to the power of 2.
Very good. And now can anyone dictate the next step in the numerator? Okay, Chris, you want to dictate the next step? X times 2x squared. Times 2x, how much?
2x. Negative, sorry.
Negative 2x squared. Perfect. X times negative 2.
So, negative 2x.
With minus in front. 1 times 2x.
Negative 2. So minus 2.
2x.
Sorry.
1 times 2x. And 1 times negative 2. With minus in front. And then I copy the rest. Perfect. What now?
Combine like terms.
Excellent. I see these two go away. Can anyone give us the final simplification for the top?
Do x squared
Very good.
minus 2x
Yes,
plus 6.
very good. I recommend, since the leading coefficient in the numerator is negative, I recommend factoring it out like we just did in the previous example. So x squared plus 2x minus 6 over x squared minus 2x plus 4 squared. How do you feel about these problems? They look difficult. I hope you can say that. But do we need practice? Yes, we absolutely need practice. Okay? So I'm kindly asking you to finish this handout between now and Wednesday. Circle the ones that you don't get. Okay? For Wednesday. So I can put this aside and forget about it. Do you think there is a need for another one?
Okay.
Okay. Please choose. And then I can put it aside.
Which one was chosen?
We chose 1, 11, and 15. We did 15 and 11.
Or, let's just do one. Number 1.
You may want to do a fraction then.
Okay, let's do one now.
Because 1 is really nothing.
Yeah, 6.
Okay. So 4, 2x minus 3 to the third, 2, 5x minus 1 squared minus 2x minus 3 to the fourth, 2, 5x minus 1, 5, and everything divided by 5x minus 1 to the fourth. Did I manage to copy from two different ones? Or I copied only from one problem? I'm checking myself. Yeah, I think I did it correctly. Good. I'm putting the attendance in. Is it done? And now I want to hear somebody else talk. So maybe Andrew wants to start on this one. What would you recommend we do first? What would you do? Yes, Nick?
So I started out by multiplying 4 times, distributing with 4.
We're not distributing anything. We cannot because of the powers. We cannot distribute anything. So by the order of operations, I have to raise to power 3 and then multiply by 4. I will never do that. So
2 of those 5x minus 1.
not yet. We haven't simplified the two terms at the top. We can't start doing that yet.
With the 2x, sorry, the think the greatest common factor is,
We're not there yet.
can we combine the 5x minus 1 to make it the third power?
No, we cannot.
You said you can multiply the 4 times inside.
No, not inside. Because I have to raise to the power first.
Some of the 4 and 2.
Exactly.
You multiply the 4 and 2.
That's it. That's all I can do. It's 8, 2x minus 3 cubed, and 5x minus 1 squared. There is nothing else. That's the most I can do with this first term. Minus.
The 5, 2, and the negative 1.
So what do I write?
10.
Very good. 2x minus 3 to the 4th and 5x minus 1. Now I'm ready for the greatest common factor.
So the greatest common factor is 5x minus 1.
Let's look again.
2x minus 3
2x minus 3, and what else?
and 5x minus 1.
And what else? 2. Very good. 2x minus 3, and 5x minus 1. Now we need to discuss powers. What is the power of 2? Just 1. Very good. What is the power of 2x plus minus 3?
3.
Yes, indeed, the smallest of the two. And what is the power for 5x minus 1? 1, indeed, you don't have to write it. Now please tell me what is left in brackets.
4.
Indeed.
2x minus 3.
Careful.
5x minus 2.
Indeed, just 5x minus 1. I reached this stage with a minus.
Minus.
Yes? Yes?
Minus
Yes?
2x.
Yes. I know it's not done, but we made a huge step forward, right? Would you agree? Everyone? Okay, what is the next step?
Flip and multiply.
Say it again.
Flip and multiply.
There is no division at the top. I can flip unless I have a fraction in the numerator. First, I'm going to do this. What is left here?
3.
Very good. So then I have 2. 2x minus 3 over 5x minus 1 to the third. And can you dictate inside parentheses? I'm ready.
Negative.
Not yet.
20x minus 4. Minus 10x plus 15.
Indeed. We simplified by one of those. I took one away and from 4.
2x minus 3 cubed.
So 2x minus 3 cubed times 2x minus 3 cubed will be 2x minus 3 to the 6th.
No, I'm talking about here, first row. You rewrote it. The 3 cubed, or you rewrote it on the second page.
On the bottom.
It's on the bottom.
It's going to be.
Oh, I'm so sorry. Yes, I'm sorry. I didn't copy it correctly. I'm sorry. Yes. Thank you. Sorry about that. Very good. So then what is the next step? (20x minus 10x).
10x
Good. And 15 minus 4.
14.
So 10x plus 11, 2x minus 3 to the third, and 5x minus 1 to the third. Okay, we're done with this. I can put it aside. You must do patiently all problems. If you get stuck by any chance, you can also read this. What I recommend is watch the video and with the lecture notes in front of you and do it again step by step, all of them. Ready? Okay. Now I would like to talk about the absolute value problems to prepare for calculus. This is another handout that I gave. Okay. Like before, I have to start with something that is a preliminary step for that. You can just jump into it before we talk about it. And I want to refresh your memory on the formal definition. When we say formal, we really mean something that works for everything, actually. Formal definition is something that is applicable in all situations. Basic definition. Okay. So the absolute value of x. We know that this is the distance between x, whatever it is, and excellent. So if I'm asked to determine the absolute value of 4, what will I say? If I'm asked to find the absolute value of 0, I will say, and let's say I'm asked to find the absolute value of -3, and I will have to say, why? Because -3, if 0 is here, -3 is found exactly 3 units away from 0. Why is the absolute value of 4? 4 is because 4 is here. It will be found exactly 4 units away from 0. Clear? Well, the problem here is that this x may not be given to us. So in general, what can happen? What can I have? What can I replace the absolute value of x by? So now let's think. What type of numbers we have? Well, many, but at least positive and negative, right? We also have complex numbers, but that's not the case here. So we have real numbers, and we have positive numbers and negative numbers, correct? And 0, you can say, doesn't belong to any category. And I will have to agree, it doesn't. So if I'm told, find the absolute value of a positive number, what will I always get? The number. One more time. So if I'm asked to find the absolute value of a number that is positive, what will the answer always be? That same number, correct? So the absolute value of a number that is positive is x if the number is positive or 0. It doesn't change if it's 0. So one more time, what did we just say? The absolute value of a number is the number itself if the number is greater than or equal to 0. But there is a second option, right? What is the second option? If what? Right. And now let's think. What will I replace the absolute value of a negative number with? But I don't have the number. So I have to have an expression that has x in it. It cannot be x. But what can it be? Exactly. The opposite of the negative number, right? Here's an example. The absolute value of the negative number is the opposite of that number. And that's how we get the negative x. We should always remember this definition because it's applicable to any absolute value applied to an expression. So now I'm going to give you something that maybe will help you in the long run. So here it is. Any expression, I'm going to call it E. Any expression in absolute value, E, is, can anyone dictate? You only have to mimic this. I just want to make sure that everyone understood it.
It's E if E is greater than or equal to 0.
Excellent.
And it's negative E if E is less than 0.
Perfect. That's all I want you to say. Thank you, Nick. That's all I want you to say. Because if I replace this, in other words, by an expression, then I have to replace it here. Same thing here. Same thing here. Careful, careful. Minus that here. So all those 5 have to be the same. Again, I'm not teaching you to memorize stuff, or mimic necessarily, but that's what this means, actually. And now we're ready. Sort of. Where's my handout? Right here. Oops. So let's go to the last page. Again, you can read the explanation and examples. There are examples in here as well. And I would like, this time I will choose first and then you will choose. I'm going to start with, and then I would like you to make one up actually. I would like to start with number 7 or 8, you choose. Whichever you want. 7 or 8. Let's start with 8. 9 minus x in absolute value plus 3x minus 5 in absolute value. And looking at this, you will say, wait a minute. What is this? And what we're trying to do, first of all, we're trying to simplify. We're trying to simplify this addition of two absolute values into anything that it's possible to simplify it to, but no absolute values at the end. Whatever I can get, but no absolute values at the end. Okay, so here's my first step. I have to take this and do this with it. Exactly what we just did a minute ago. Any expression. I said any expression. Any expression can be 9 minus x. Also, any expression can be 3x minus 5. As long as I carefully plug it in here, carefully. So I would like you to dictate.
Equal to 9x.
Careful.
9 minus
9 minus x.
If 9 minus x is greater than or equal to 0. And negative 9 minus x.
With parenthesis.
If 9 minus x is less than 0.
Perfect. I could have not said it better. Yes.
Now, could that be?
You don't switch anything, don't know. Careful. 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 All these 5 have to be identical. 1, 2, 3, 4, 5. You can distribute this symbol, and we will in a minute. This is not done, though. We're not finished simplifying the absolute value of 9 minus x. We have one more step to go. So that equals 9 minus x if I must solve this inequality now. How do I solve this inequality? I can move negative x to the other side and read it from here. X is less than or equal to 9, because if you move 9, then you have to divide by negative 1, and you still have to switch the symbol. So I will say if x is less than or equal to 9. If you don't understand that, please let me know now. Is that okay? Okay. So now the other one will be negative 9 plus x if I refuse to look at this and I refuse to solve it. If the first inequality is less than or equal to 9, what should the other inequality be?
Negative 9.
No, the rest of the real line. The rest of the real line, the number line. What is the rest? If this says x less than or equal to 9, what will be the rest?
It's greater than 9.
Of course. Absolutely. This is a function defined everywhere on all real numbers. It has to be. If you want to spend your time, you can. You can solve it. You will move negative x to this side. It becomes positive, so x greater than 9. But I don't recommend it. You may make a mistake. Who knows what's happening there? Perfect. So now this is fully simplified. I'm hoping that somebody else will simplify for us 3x minus 5. Someone other than Nick. Nothing personal, Nick. He's punished. Parker?
No, which handout is this in?
It says simply, it says absolute value exercises for this one.
That's fine.
Yes, the last page. Okay, I'm waiting for anyone else other than Nick to help with this. No?
3x minus 5 if 3x minus 5 is greater than 0
Or equal to.
or equal to.
You're right. You can put the equal 0 on the other one if you want to. It doesn't matter. So in other words, the definition can be written like this: greater than or equal to 0, less than 0, or greater than 0 and less than or equal to. It doesn't matter where you put the 0. We prefer to put it with a positive, but it doesn't matter. So you can keep this strict inequality and put the equal here, but not in both. That would be a mistake. Okay, good. Perfect. First step, perfect.
And then negative in parentheses 3x minus 5 if negative 3x minus.
We cannot change anything
Oh.
there, remember? Count.
Oh, yeah.
Count. 1, 2, 3, 4, 5, identical. 1, 2, 3, 4, 5 must be identical. Okay? If
3x minus 5 is less than 0.
that's it. Now, can anyone give us the next step?
Something forward.
Yes. Other than Nick and Noah.
You add 5 to
Shane?
both sides. You add 5 to both sides and divide by 3. So
Yes.
x is greater than or equal to 5/3.
Excellent. And what will be the other one without even looking?
X is less than or equal to 5/3.
Not equal to.
Oh,
I cannot have equal in both.
less than.
Exactly. Exactly the opposite. That is not in the first one, must be in the second one. So then the second branch is what?
Negative 3x plus 5.
Very good. Okay, now what? We simplified each absolute value. We simplified this and we simplified this. What's next?
Wait, is it 3x minus 5 still? Is it
Negative
plus
3x
Oh,
plus 5.
okay. Yeah.
So there is a minus in front of the expression. Minus in front of the expression has to be distributed to everything. Was that the question?
Yeah.
Okay, clear now?
Yep.
Perfect. Okay, so here's what I recommend. Because this is not done. We only simplified each individual absolute values, but now we have to simplify the entire expression. So let's do that. I love charts. I cannot take credit for them. I was taught that way. And I do love those charts. Because they summarize the information and I just see it right there. What will I have in the chart? Well, x, because x is the variable in the problem, and it goes from negative infinity to infinity. Then I will have in the chart the first absolute value as the first row in the chart, and then 3x minus 5 in absolute value as the next row in the chart. And of course, the last row will be what? What do you think?
Both.
The expression. This is what I'm trying to simplify. Not each by itself, but I had no choice. I had to simplify each by itself first. But what I'm really interested, that's my target. The whole expression. That would be on the last row. So the absolute value of 9 minus x plus the absolute value of 3x minus 5. This is my target. I don't care for the individual ones, but I had no choice. I had to build slowly till I get to the roof, right? Okay, so which x values should be in the chart and why? Nick?
Like a dumb answer, but shouldn't all the x values be in there and you cancel them out in the chart?
Don't be afraid to be wrong. Which, you can put any values you want, but the values that are mandatory to be in the chart will be,
X minus x.
no, and y. So what type of function is this? If we want to talk about a function, what type of function is this? How do we call it? Excellent. So piecewise defined function. We graphed it even today, right? Half an hour ago. What type of function is this if we look at it as a function? Piecewise defined function. So a piecewise defined function is defined in pieces, and each of these two have two pieces, and they have a key number.
So we 5/3 times.
number. Yes, 9. Why 9 is a key number for the first one?
Because it's greater than 0.
Nope.
It's a number.
Something happens
It
there.
starts at 9.
Exactly, it changes the function. Exactly at 9 is from here to there. Well, who knows what? 9 is the key number. Okay, what key number do we have in the second function? Absolute, that's all we need. Only those key numbers, nothing else. In order from left to right, we cannot just put them in. So I have to have 5/3 and I have to have 9. Nothing else matters here. I'm sorry?
We just plug this in.
Nope. Hold on. Good. So now I'm going back and trying to make sense of this. So here's how I make sense of this information. So listen to what I have to say. The absolute value of 9 minus x can be replaced by 9 minus x if x is to the left of 9. It can be replaced by negative 9 plus x if x is to the right of 9. And that's what I'm going to put in my chart. One more time. The absolute value of 9 minus x can be replaced by 9 minus x. Where? Only when x is less than or equal to 9. And it can be replaced by negative 9 plus x. Where? Only if x is greater than 9. X greater than 9, negative 9 plus x. X less than 9, 9 minus x. One more time. This is very important. If we understand it now, we're not going to have any problems with this. This information, the simplification of the absolute value of 9 minus x, it really tells me that I can replace it by 9 minus x for x values less than or equal to 9. For x values less than or equal to 9, I have 9 minus x. It also tells me that I can replace it by negative 9 plus x for x values greater than 9. Who volunteers for 3x minus 5 to tell me what to write and where? What do I write in the first? As you see, there are 3 subintervals.
3x minus 5.
What do I write in the first subinterval?
Negative 3x plus 5.
Do you all agree? It's right here.
Oh, yeah.
It's negative 3x plus 5 for x less than 5/3.
Miss the negative.
Oh, okay. Yeah. So negative 3x plus 5. What do I write in the second subinterval?
3x minus 5.
Do you all agree with 3x minus 5? And what do I write in the third subinterval? Do you all agree? So now I see that I will have 3 different options because I have 3 different subintervals. This subinterval will give me an option, this subinterval will give me another option, and this one will give me another option. What am I doing with these? I'm adding them. So on this subinterval, I have to add 9 minus x to negative 3x plus 5 because that's what I'm told to do. On this subinterval, I will add 9 minus x to 3x minus 5, and I'm going to get an answer. And on this subinterval, I add negative 9 plus x to 3x minus 5, and I'll get a different answer. So please add these terms, like terms, and tell me what to write.
14 minus 4.
We are multiplying. We are adding. We are adding. So negative 3x minus x is negative 4x. Oh, you said 14. I'm sorry. You started with, yeah.
I'm sorry there.
You're right, but we have to put it in descending order. Sorry, my mistake. So the second term, a second possibility.
2x plus 5 plus 4.
Good. And the last possibility?
4x minus 14.
Good. So therefore, the answer is this. The absolute value of 9 minus x plus the absolute of 3x minus 5 is... Can anyone dictate the answer now, please?
Is negative 4x plus 14 if 9 minus x.
If x is less than or equal to 5/3, this is the interval. Are we? Yes. Very good. That's the interval. Good. Second branch.
2x plus 4 x is
If 5/3,
5 is
and the last branch, it's the interval. The interval tell us
If 9 is,
if x is to the right of 9. Any questions?
so now when you put the
Nope, as long as it's only once. So you can have the equal symbol here, but not here. You can have the equal symbol here, but not here. If you put it here, you cannot put it here. Doesn't matter. You choose, but only once for each number. Nick?
can you explain the middle answer?
Yes, x is between 5/3 and 9.
Oh, okay.
And this is 2x plus 4. Any questions? Okay, let's choose another. So I can put this handout away for good.
Here you said we're going 7.
Oh yeah,
7.
7. So the absolute value of x minus 1 minus the absolute value of x plus 2. Please simplify each absolute value first and tell me what you get. Okay. Do we have x minus 1 in absolute value? Anyone?
there's the x minus 1 if x minus 1 is greater or equal to 0.
Which was easy to say, x greater to 1. The other ones were a little bit more, required more work. And
Negative x minus or plus 1 if x less than
if this is greater than or equal to, this one cannot be greater than or equal to.
less than
It has to be the opposite.
Why are you choosing 1 instead of 0?
X minus 1 greater than or equal to 0 means x greater than or equal to 1. We skipped a step. X minus 1 greater than or equal to 0 means x greater than or equal to 1.
So,
Yes.
if you subtract 1 from, so if you said that,
You're adding 1 to both sides.
yeah, so, well, it's negative x plus 1 is less than 0. Like the original equation.
No, all 5 have to be the same. All 5 have to be the same. You cannot change this second one with negative x plus 1 or something. All these have to be identical. If this is x minus 1, this is x minus 1, this is x minus 1, this is minus x minus 1, and this is x minus 1.
Yeah, so when we get to minus 1, you flip that, but when you divide by negative 1, when it flip the
There is
equation,
no negative 1 here. I'm not dividing. There is no x. There is no negative in front of x for this one. The leading coefficient is positive, so I would not be dividing or multiplying by -1. Better?
Yeah.
Perfect. Can anyone give us the absolute value of x plus 2, please? Andrew, how are you feeling with this? Okay, can you?
X plus 2.
Yes?
X is greater than or equal to -2.
Excellent.
And then
Very good.
negative x minus 2
Excellent.
if x is less than or equal to 2.
Excellent. Perfect. So now we can go ahead to the chart. So we have x minus 1 in absolute value. Of course, x has to be at the top between -infinity and infinity. And x plus 2. And what is the third row? Or if you want the fourth.
The original
Yes, the original problem. Very good. X minus 1 minus the absolute value of x plus 2. Perfect. What numbers we need in the chart? That's it. And they have to be in the ascending order. How many subintervals we have? 3. How many expressions will we come up with? Good. How will you summarize the information now inside the, oops, it's 6:45. Can you finish this one? The reason why I like to stop on time is because I respect you, and second,